Hi everyone, welcome to my session. Today we're going to be talking about storing and searching files in SQL Server file tables. This is one of my favorite features in SQL Server. It's been around since SQL Server 2012. Surprisingly, not many people know about it, but once you learn it, you're going to love it, just like I have. So let's go ahead and get started. A little bit about me. First and foremost, my Twitter handle, @SamNasr. I've been a software developer since 1995. I'm a senior software engineer for NIS Technologies, where I've been certified with several certifications from Microsoft. I'm also active in the Cleveland C# VB.NET user group, and as well as the .NET study group, which meets online. I've authored approximately 17 articles for Visual Studio Magazine, and I've been a 5-time Microsoft MVP. So let's start with an overview of file tables. What is a file table? Essentially, it is a table that contains metadata on files in a specific directory. So it's a table type with a predefined schema. Once we create the file table, we can't alter it. It is a predefined schema out of the box that contains metadata regarding all the files. It utilizes a feature that was introduced in 2008 called FileStream, and that feature, as well as the hierarchy ID, are used in the file table itself. So it uses a shared folder that is specified in the file stream, and what it does is the file stream allows us to be able to store files in a file group on the disk, but it is controlled by SQL Server. At the same time, it is not stored inside the database. So it gives us the advantage where the data is not bloated, but we have full control over the file itself that's on the file system contained within the file groups. And we'll see more about that as we step through the demo. So once we create a file table, its contents are basically where every row represents a file or a directory in that shared folder that's being created. We have a file stream column within that table that essentially points to the stream of data of that file sitting on the file system. In addition, we have a path locator and a parent path locator columns inside the file table where it represents the file or the directory hierarchy. So it uses the hierarchy ID to show us exactly where that file or folder are located in the overall hierarchy of the file system. So in addition, we have also 10 file attributes that pertain to each file or folder within that shared folder. We also have a type column that specifies what type of file we're working with, and that allows us to utilize full text search and semantic search over these documents that we're going to create within that shared folder. So taking a closer look at hierarchy ID, basically it is a system data type that was introduced in SQL Server 2008. And it's a variable length data type, and it gives us the ability to do a representation of a tree or the hierarchy of a tree and specify that in a single data field. We can use the toString method to convert the hierarchy ID to a nvarchar, and that allows us to see the data and make it more human readable as opposed to seeing what appears to be encrypted data. Within the hierarchy ID, there are multiple methods that we can use to be able to find out where that file is. So if you could imagine you have a file structure inside of a specific shared folder. You want to be able to identify a specific file within that hierarchy, and you want to be able to find out in what folder it belongs into and what folders are underneath it and what other files are at the same level. So here's a variety of different methods that allow us to access that. So we've talked about file tables, we talked about what it contains and that it's essentially a representation of a shared folder, and it's controlled by SQL Server, but the files themselves are sitting in the file groups, so they're not bloating the database. So now we want to get started and go ahead and implement it. Before we do that, we have to configure it. Part of that configuration involves either the machine level configuration during the installation, where we can specify, there you see in the screen caption, here I was installing SQL Server 2012, and part of that you see that there's a file stream tab at the very end. I can check to see that it is enabled for FileStream for Transact SQL access. I can also enable it for file I/O access, which means I'm enabling users to be able to access the files inside the file groups through SQL Server. And I can also allow remote access, meaning someone outside the server to access that. So there it allows for remote clients to access that file stream data. Now, file stream data and hierarchy are both subtopics that we could spend a great deal of time on, but essentially the critical part that you need to know is that a file stream, it points to a file sitting on the file groups managed by SQL Server, but it is not sitting inside of a database. So it helps to answer that old dilemma, where do I store files so that I have full control over them? We created part of the file group and we control it through SQL Server, and part of that control happens with the configuration process. So as I was saying, we can do this at the machine level during the installation. In addition, after installation, we can go through SQL Server Configuration Manager, and there we have the same settings available where we can turn it on or off and then specify what the shared folder name will be. And here you see the default instance is MS SQL Server. A third option is that once we start the server instance, we can also implement the file streams through stored procedure. And so we can utilize the SP configure file stream access level. And basically this is a stored procedure that allows us to configure file stream access level, just as the name specifies. And then there you see that there is a n parameter that's specified at the end. What this n signifies is basically one of the three check marks that we had seen in previous slides. Do we want to enable or disable file stream completely? Do we want to enable it for T-SQL access only? Or do we want to go full out and allow remote access as well? And so there you see the three levels of n equals 0, 1, and 2, where we can specify whether we want it disabled, whether we want to enable it for T-SQL access, or full remote access as well. So once we've set up the configuration, now we want to actually enable the file table. So to enable the file table and be able to use it, essentially it's a four-step process. First, we have to enable file stream at the instance level, as I mentioned before. Then we have to provide a file stream file group. And you'll see as we create in the demo that we have to specify that as part of the file groups. We also have to enable non-transactional access at the database level because, again, these are files that we're dealing with. So we want to enable non-transactional access. And last but not least, since FileTables is essentially pointing to a shared folder, we want to specify where that directory is going to be located on the file system. So again, 4 key steps that are needed in order to enable FileTables. Let's jump into a demo and take a closer look at it. Going into SQL Server Management Studio, here's my script. And there I have Object Explorer on the left, and there you see I do not have the database created as of yet. So, first off, this is supported in all editions of SQL Server 2016 and later. Supported in versions of 2012 and later for file streams. So let's go ahead and correct that. So first you'll see that file tables are supported in every edition of SQL Server 2012 and later. And in this case, I'm using SQL Express as my demo. And so the first thing that I need to do is to enable file streams at the instance level. And if you recall, there's 3 ways I can do that. I can do that during installation. I can do that through Configuration Manager. Or the third option, I can do it through T-SQL, as you see here, by calling a stored procedure. So I'm going to go ahead and execute that stored procedure. And in my scenario, I want to allow remote access as well. So I'm going to set the n level to 2. I'll go ahead and highlight that portion and execute. And there you see that it changed from 2 to 2, meaning that since I had it, since I had run this previously on this machine, that it changed it from level 2 to the current level of 2. So obviously no change there. But my file stream is configured, so I ensured that. The next thing I need to do, if you recall, step 2, I need to specify a file stream group inside of my file groups. So let's back up for a second. Whenever we create a database, what are the things that we have to specify? We have to specify the folder where that's going to be created for the both MDF as well as the LDF. Now, in this case, since we're using FileTables, there's an additional clause that goes in, and in this case, there it is. So I'm going to create file group using the file group clause. I'm going to specify what it's going to be called, cars fs group 2, and that it's going to contain file stream and the path where it's going to be located. So jumping to my file system, you see that on my C drive, I have a FileTables Demo 2 folder created, and it's currently empty. So in this specific portion of the SQL, it's going to check to see that I don't have my database called cars, that it's not created. And if it is, it's going to drop it. Otherwise, if it doesn't exist, I'm going to go ahead and create it, and I'm going to call it cars2. So let's go ahead and highlight this portion and execute it. And there you see the command completed successfully. If I jump back to my file system, there you see that I have my MDF, my LDF, and in addition, I have a folder called cars file stream 2 as specified in my file group clause here. So this folder, typically, it's going to be off limits. You don't want to get into it on a regular basis. However, for demonstration purposes, I'm going to take you there. And if you notice, as soon as I open it, it's saying that I currently do not have permission to access this folder. As administrator, and for demo purposes, I'm going to go beyond that just to show you the contents of it. Typically, you would never have to access this folder. This is something used under the hood by SQL Server, and so you typically don't have to access it. So right now, I have a $fslog folder that's currently empty, and I have a .hdr file that is currently 1K. So that's my entire contents within this cars file stream. Let's go back to our T-SQL. And now the third step is I need to enable non-transactional access. So what I'm going to do is alter the database cars2, set non-transact access to full, and point to that file stream that I'd created in the previous step. In this case, I called it cars data fs2. And there you see the name listed above within the file group. And so I'll go ahead and execute the statement. And there you see command executed. Now in this step, I have it in the sample SQL, where if you want to check to see what the directory name is and if non-transactional access is enabled, I can simply query the database file stream options table. And so I'm going to query it. And there you see that I have the cars2 database. It's pointing to the cars data fs2 folder or directory. And in fact, non-transact access is set to 2. And the description is full access, essentially, which means remote access as well. Okay. Now the rubber meets the road. So we're going to change the database to our cars2 database. And we're going to take a look at our Object Explorer and refresh that. And we see there's our cars2 database. If we expand the tables folder, we see that we have 4 folders, one of which is FileTables. Currently, this folder is empty, but we'll go ahead and change that. And we'll go ahead and create a file table, and we're going to call that cars.store. So basically, the example that I'm following is if we had a used car lot, for example. We have cars coming in, customers purchasing them, cars going out. And so we want an inventory of the spec sheets of all the vehicles that are in inventory. So this will help us facilitate that. But first things first, taking a look at the file table. Typically, when you create a table, what are some of the things that you have to specify? You have to specify the column name, column type, whether it's nullable or not. You can also identify primary keys during the creation of a table. So it can be pretty lengthy. With a file table, on the other hand, it's a predefined schema. So we can't alter it, we can't change it. There isn't much that we can do other than create the table. Hence, you see the statement, create table car.store as file table. And that's it. So we highlight it and execute it, and we jump over to our Object Explorer, refresh, and there under tables, we see that we have a file tables folder, and there's our DBO car.store. When we expand that, we see that we have 17 different columns. We have a stream ID, which is a unique identifier, as you would need a unique identifier for every table. We have a file stream, which is essentially a var binary max. This is pointing to the contents of the file sitting on the file group, the name of that file, the path locator and the parent path locator, which are both hierarchy ID data types. Again, hierarchy ID allows us to identify where a file is in the file system. Think of a tree structure. It will tell us how deep it is vertically, as well as how many over horizontally. And then we have other metadata pertaining to that file. So we have file type, the size, creation time. In addition, we have all the attributes regarding whether it's hidden, whether it's read-only, so on and so forth. In addition, if I was to right-click on this, I have the option to explore file table directory. When I click that, now it's going to take me over to the folder that's on the file system, controlled by the file groups and SQL Server, but it's actually sitting on the disk. And so there you see my path. It appears to be a shared folder, and you can quote me on that later when I say appears to be, because you'll see that it'll go away, and we can make it reappear again. In any case, if you look at the naming scheme, we have the name of the server, the name of the instance, the name of the file group that we created, cars data fs2 for the file streams, and then cars.store is the name of the file table that we created. So now if I select from the cars.store, because I just created the table, naturally there are no rows in it, but there we see all the 17 fields returning empty. Now I'm going to go back to my demo files. And that is located over on my hard drive. So go to C and then file tables. And there we see that we have a set of demo files. Again, our example is basically a used car lot. We have cars coming in. Every car that comes in has a spec sheet. So let's take a look at this one, for example. We have an Audi A6, and I stored the spec sheet in a flat text file to make things easy. So, as you would think, every vehicle has a model year, mileage, a body type, in this case it's a sedan, the engine size, and then various metadata pertaining to that vehicle. It's got a white exterior, a black interior, and the interior material is leather. And I did the same thing for several other vehicles. In addition, I created this SUVs folder, where inside I have the quote-unquote spec sheet for a Chevrolet Silverado, and we can take a peek at that. So essentially, it's several text files that I'll be importing. Now, when we last queried the file table, you'll notice it was empty. So what I'm going to do is I'm going to go to my folder for where I'm keeping all my demo files. And let's just say that I had a car carrier come into my lot and it dropped off several vehicles, and here are the spec sheets for them. So now I will click and drag all these files over into my shared folder, select copy, and now immediately I'm going to go over into SQL Server Management Studio. I'm going to reselect everything from the cars.store file table. And there you see that it returned 6 records. 6 records pertaining, one for every file and or folder that's in that shared folder. And that shared folder being the folder that's created by SQL Server for me. That is, pardon me, that is this folder. Okay? So, as we had mentioned before, every file has a unique identifier. We're going to call that stream_ID. Then it has a file stream that's pointing to the contents of that file, and looking at it, it is non-human readable data. So it seems to be encrypted data, and in addition, we also have the file name, CadillacSeville.txt, FordMustangGT.txt. There's the Audi that we looked at. And if you notice the SUVs folder, because it's a folder, that folder itself does not have a stream of data, but rather it is a container that contains other files within it. And then if we continue on, we see that we have a variety of other data types pertaining to that file. So essentially, everything that I had done to that shared folder immediately got duplicated in the file table. But could the opposite be true? What if we were to modify that table using T-SQL? Will it reflect over into the shared folder? Let's take a look. So the following section, I have an update statement where I'm going to be updating my file tables, singular file table, and I'm going to be modifying the read-only attribute where the file name is FordMustang.txt. And so first of all, I want to highlight where that record is, and that is the second record that was returned. And we see that the read-only attribute for it is set. There it is, set to 1. So I'm going to update it. Actually, before I do that, let me do one more thing. Let's go over into my shared folder. I'm going to highlight the Mustang file, select Properties, and there we see, in fact, that the read-only attribute is set. We'll cancel out of that. We'll go back to Management Studio. There's my update statement. I'll go ahead and execute that, and there we see that one row has been affected. When I go back to my shared folder, I right-click on it again, select Properties, and it is no longer read-only. So what I demonstrated here is basically whatever we place in that folder will be reflected in file tables. Whatever modification we make in that file table will be reflected in the folder. So we have a one-to-one relationship. In addition, if I was to delete an entire record, so here we have the BuickRegal.txt. Let's say that that gets sold or removed off of our lot for whatever reason. And taking a peek at the folder structure, there I see the BuickRegal.txt. If I was to go ahead and delete that file or that record, it will automatically impact what's over in the folder. Now there you still see it, but if I was to do a refresh, it's gone. So once again, we have that one-to-one correlation of what's in the shared folder with what's in the table. So let's continue looking at the contents of our file table. If you recall, there were 17 different columns returned, and some of them were actually a hierarchy ID. Now, with a hierarchy ID, what I could do is identify what the locations are of specific folders. So what I'm going to do is I'm going to select on the path locator, and I'm just going to call it file location, and then the parent path locator, and call that the parent folder. When I query it, there we see that we have 4 files, and they're coming back, and the parent folder is null. But we have one file that does have an ID for a parent folder. And as you might have guessed, that is, here are my 4 entities at the root, and looking at the SUVs folder, that has only one file. Now looking at this, it's not exactly human readable. You can't really make sense out of it. So what we can do is implement the toString method on these two columns because they're hierarchy IDs. And it represents the ID in a little bit more of a readable fashion. So taking a look at that specific file, the Chevy Silverado, you'll see that, again, all the other files do not have a parent folder because they're at the root, but the Chevy Silverado does point to a specific folder. It does have a parent. And so when we look at the parent, that is /24593, we see that there's another folder here with that ID. And so taking a look at the Chevy Silverado file specifically, you'll see that there's a slash syntax to show that it is contained inside of a subdirectory. And that parent directory is not only listed here in the parent folder, but it's also listed in the beginning portion of that name right before the slash. So the hierarchy ID helps us to identify where we're at in the folder structure that's contained within the shared folder. So now I demonstrated how we can actually have a one-to-one correlation where basically all I do is click and drag files over into my file tables. All the metadata gets imported into SQL Server immediately, and I have this nice interface of basically what appears to be a shared folder. And let's go up a level to see everything. So it makes it very convenient for someone who's non-technical. If they get a variety of different spec sheets and they want to import them into the database, they can do that just by a simple click and drag. Now, we want to build on top of FileTable and search the actual files that are there, following along with the title of the presentation. And so one of the things that we need to do is implement full text search. So with full text search, basically there's a variety of different data types that we can use for searching, and they're already built into SQL Server. And to see what files are already there, I can query the table sys.fullTextDocumentTypes. And if I query the entire table, there you see approximately 50 different file types that I can query. More specifically, if I implement this where clause, you'll see that .txt is one of them. Also, as you notice in the comment that I have here in the script, additional filter packs are available for other file types. So you're not just contained just to what's in here, but you can also get additional filter packs and install them. Now let's go back to our database. And we want to select from SysTables just to get a picture of what's there. And so there it shows us that we have the cars doc store, and that is a user table. If we want to query file tables to find out how many file tables we have in our database, again, there is the object ID, and it's pointing to the file table, and it's telling us that the directory name is cars doc store. If I want to search and see how many file groups I have set, there it shows me two file groups. We have the primary, and then we have one for the cars file stream called cars FS group 2. And it's essentially a file stream data file group. So I've checked to see that I have my file tables there. I've checked to see that the .txt is supported. What can I do to get full text search implemented? Basically, the first thing I would need to do is create a full text catalog. And so to do that, again, simple T-SQL statement where I specify create full text catalog, and then I give it a name. I got very specific here. I called it my full text catalog. I'm going to go ahead and implement that SQL. And there we see that it completed successfully. So now I have a full text catalog that's available to me. How can I populate that full text catalog with the data that I have in my file table? I do that by this following T-SQL statement. So let's step through it in more detail. I'm going to create a full text index on my file table. I'm using the language 1033, which is basically US English. I'm specifying that I'm looking at the file stream type and the column file type. And again, there I'm using the language 1033 or the code for US English. And then one critical piece here, I have to specify what the primary key is for that table. Now, if you recall, when we created the file table, we didn't specify anything. It was a predefined schema. We just said create file table, and it was created for us automatically. So how do we find out what that primary key is? Because it is a predefined schema, the primary key is already created for us. What I have to do is actually obtain that primary key, and I do that by going down to the keys folder, and there's my primary key. I'm going to copy it because I need to paste it in here. And the reason I need to paste it is every time I create a file table, that primary key is going to be created with this rather ugly naming convention. And it's rather ugly because it's unique. Again, I can have multiple file tables in my database. So how is that primary key going to stand out for that file table? This is the syntax that's used to create a unique primary key for that. So every time I create a file table, I need to get that primary key. And if I'm going to be implementing full text search, I have to specify that in my statement. Hence the cut and paste. I'm a developer, so I always use cut and paste. In any case, so we've gotten this far into the statement, and I'm saying that I want to implement that full text on to the catalog that I created in the previous step, which is my full text catalog as specified here. And then some additional parameters. I'm leaving the change tracking set to auto and the stop list set to system. And I don't want to get into more detail because, again, these are different subtopics that could take up an entire hour, if not more, on their own. So the short of it I am creating a full text search on that file table, which is essentially pointing to files sitting out on a directory. And I'll go ahead and click execute. And we see it's going to chug. It's going to take a little bit. And it's essentially indexing all the files that are in my file table, which are essentially all the files that are in my folder. Okay, so now our full text has been implemented on our file table, and there we see the command has completed successfully. So our next step is to actually be able to query files from there pertaining to the text that's in them. Before we do that, I want to take a look at the select file table root path, and what this will do, it will programmatically through T-SQL provide you with the location of where those files are located. So again, I just did a simple select file table root path, and it brings back the path of where the files are stored. If I take a look at my cars doc store, which is my file table, I see that I have the 4 files in there plus the SUV, which is the Chevy Silverado, but I don't have the Buick file in there. And that's going to be intentional. As we move forward, now that I have full text already implemented on that table, I want to be able to search for my customers, find out if, let's say a customer comes in and he's looking for a V6 model with leather. So now I can implement it using this T-SQL, where I'm specifying in my where clause that it contains inside the file stream column that it has text that specifies V6 and leather. And so when I do a select statement, there it brings back 2 files. So I have my Audi A6 and my Cadillac Seville, which are both V6 and leather. And if you don't believe me, which you shouldn't, let's take a look at the text file. Okay, let's take a look at its parent. And there we see the Audi A6 before it was copied over. And it has leather, and it has a V6. In addition, the Cadillac Seville, leather, and v6. So we're not able to query the files that are in my file table for specific text that's in them and be able to retrieve it all within T-SQL. Now, I want to touch on something. Earlier, I tried to open up this file inside of my file group. And when I did a double click on it to open it, there I get the error message that says the request is not supported. And that is because it is currently inside the folder that's managed by SQL Server. However, if I was to copy that file, and let's take the Cadillac Seville, copy it over to my desktop, now I can read it without an issue. In order to be able to read a file that's inside the file group or the file table folder, there's additional steps that I have to go through FileStream to be able to access that. However, for someone who's not very technical or without having to write an app, just simply click and drag the file outside or make a copy of it into another location, and it will copy the contents of it and make it readily available. So let's go ahead and get rid of that, and we'll go back to our demo. So now it produced the two rows, but if I want to get specific as far as the file name that I need and where it's located for items that have a v6 and leather, I can select the file stream, and here you'll notice that on the file stream column, I'm implementing the get file namespace path method. You can read more about it at the reference link listed above, but essentially what this is doing is it's returning the full path to that file. And so once I select it, there we see the full path, and if I expand it, including the file name and extension, so it's a direct pointer to where that file is located on the file system. It appears to be a UNC path, and there you see the double slashes there, the name of the server, the instance of the database that I'm running in, the folder for the file stream object, and then the folder structure as well as the file name. Okay, so I hope this gives you a good idea of what file tables are and how we can actually copy files into it and be able to implement full text search. But if you recall, I also mentioned that once we created the file tables, we were able to right click on the file table in Object Explorer and then specify Explore File Table Directory. So what that produced was essentially a UNC path where I can click and drag files over it. But is that really a UNC path? We can enable and disable file tables within our system, and to do that, essentially, when we disable it, the columns and the data are not physically dropped from the table, but rather they are just simply disabled from access through the folder or the UNC path. The files and the subdirectories disappear from the file system, and they're not available for I/O access. So since I'm disabling file table, basically it shuts off access to all the files that are in there, and it makes my UNC path appear as if it was invisible. So let's take a closer look at that, and we'll go back to our folder. So first of all, I want to be able to select everything from the car dock store, and there you see that I have 5 objects. Now if I was to disable that, first of all, here's the UNC path that it's pointing to. Now I'm going to scroll down, and I'm going to alter the car dock store, which is my file table, and I'm going to specify that I want to disable the file table namespace. Once I highlight that statement and select execute, it'll be just a second until it disables it. So the statement for disabling the file table namespace has now executed successfully. If we take a look at our shared folder and we refresh the folder, you'll see that we get an error message saying that the folder is no longer available. So although it appeared as a network shared folder, it really is provided by SQL Server, and we can disable that folder and not make it visible to anybody. So let's minimize that and go back. And as mentioned previously, although the file table namespace has been disabled, the table is still there, and we can actually delete records from it and manipulate it via T-SQL. So I will go ahead and do that. And you see that 0 rows have been affected because the table has been disabled. But if we enable it again, and we go back to our folder, we'll have to go back to the file table, explore file table directory. So after executing the alter table and disabling the file table namespace, we see that the command has completed successfully. We switch to our folder view, and now when we refresh that folder, we see that we get an error message stating that the folder is no longer there. It is unavailable. And the reason for that is because, obviously, we disabled it through SQL Server. So what had appeared to be a UNC shared network path is really a folder that's managed by SQL Server. So let's go ahead and exit out of this error, and then we'll go back. And if you recall, when we disabled it, we had several files that were inside the car doc store. And I can query those files. And when we select for all those files, we see that everything is still there. Likewise, I can continue to manipulate that table even though the file table namespace has been disabled, but I can delete records from it. And we see that we have 5 rows that have been affected. And now I can re-enable the file table namespace again using the alter table statement. Now I go back to my folder and I select Explore File Table Directory. And there you see my what appears to be a UNC path is now back and it's available. If you notice, there are no files in it because I had deleted everything from the table. So now it's recreating everything out of the table and presenting it into a folder. In this case, there are no files. I can continue on with my operation where I'm just going to drag 2 files in at this time. And now when I select from the table, we see that we have just those 2 files again. Now, if I was to execute any statement against the table and run into an issue, these following procedures, store procedures, come in very handy that essentially allow me to kill any file stream non-transacted handles. And I can also specify it for a specific table. So either of these would work by killing any lingering threads that are not that have not reached conclusion, and they continue to run on for a long period of time. In addition, as I mentioned previously, another thing I wanted to mention is that with the file tables, I can create more than one in a database. So I've already created the cars doc store. I can create a cars doc store 2. Let me highlight that one. And I will create a third one. And I'll go back to my database and refresh. Naturally, you see the 3 file tables under the file tables folder. When I select to explore those, again, each table has a separate UNC path, not conflicting with the others. So here's the original cars doc store. Here's car doc store 2. So now after I created my cars doc store 3, I can go over to my Object Explorer and right-click on it and select Explore File Table Directory. And likewise, it will open up a separate UNC path for that table. Let's jump back to our PowerPoint presentation. And actually, we want to go to the next slide where we talked about re-enabling it. So when you enable the file table and the namespace, what's actually happening is that it's checking to see if there are any inconsistencies that are found. If there are, then an error is raised and the file table remains disabled. By inconsistencies that are being checked, I'm referring to the folder on the file system in comparison with the table. If somehow those two are not in sync, if someone goes into that folder as they're not supposed to, as I was showing you before, and this is the folder that I'm referring to, if we go to our C folder, we created a FileTables demo 2 and this cars FileStream 2 folder. If I go into it, even though I'm not supposed to, and I change things around, when I re-enable the file table, it checks to see that that folder is in sync with that table, and if not, that's when an error is raised and the file table will remain disabled and the UNC path will not be available. So that is what is meant by the inconsistency check. In addition, if no inconsistencies are found, then the file table is re-enabled, the UNC path is made available, and all is good once again. So files and subdirectories become visible in the file system, and they're also available for I/O access depending on the setting that we set in the configuration manager or the store procedure. If you recall, there were 3 settings that allows us to enable FileStream, allow transactional access, and then allow remote access for these files. So if everything is kosher, once we re-enable the file table, then everything will once again become available for access. So it also checks to see that the file table semantics are enforced and they are restored. Some restrictions regarding file tables in general. Because it is a predefined schema, we cannot change, drop, or disable the system-defined columns in that table. We cannot add new user columns, computed columns, or persisted computed columns to a file table. So essentially, what we're given is what we have to work with. We cannot modify it. And as a recap, just wanted to touch on that a file table is a table containing metadata on the files in a specific directory, as mentioned previously, and that essentially anything that's copied into that folder will be mimicked into that table, and I can see all the metadata pertaining to all the entries into that folder. It uses a share specified in the file stream. As we had seen before, it creates what appears to be a UNC path that's available, and folks can copy files into it, and those files are replicated in the table itself. Enabling file tables, again, we check for consistencies and make sure that what we have in the table is consistent with what we have on the file system. To enable the file tables, in general, we have to enable FileStream at the instance level, provide a FileStream file group, as mentioned as part of the clause when we're creating the file groups. We have to enable non-transactional access at the database level. And last but not least, we have to specify a directory on our file system where the file table will be using to access various files. Some resources. Docs.microsoft.com has some great write-ups regarding file tables. Also, restrictions regarding what we can create or alter on the file table. Essentially, there isn't a whole lot that we can alter on there, and there's a good article on that. And lastly, using the file tables in the demo, you can see my article that's written in Visual Studio Magazine, and there's the link there. My contact information, snasr@nistechnologies.com. Feel free to email me any questions. Although the presentation is coming to an end, this doesn't mean that the conversation stops here. Feel free to email me with any questions once you download the code and run the demo. If you have any issues, please feel free to email me. You can also reach out to me on Twitter @SamNasr, and I invite you all to connect with me on LinkedIn. In addition, you can also jump over to the chat, and I will be there to answer any questions you might have regarding this presentation. So thank you for attending, and some last closing thoughts. Wanted to give a special thank you to Microsoft for supporting the Data Platform Geeks and SQL Server Geeks community initiatives. It wouldn't be possible without them, and we truly appreciate it. And also wanted to thank you all again for attending, and feel free to post any images or give feedback regarding this session. So thank you for your time, and look forward to seeing you again post-COVID.